Hello grade 11. Today we will start to talk about gas law. The difference between gas and liquid, both of them are fluid, but the difference is gas is compressible, liquid is not. This due to the distance between its particles. The particle of gas have big distance between them, and also they move in all direction. The properties of gas. Number one, the molecules are in continuous random motion. This motion of gas particles called Brownian motion, and this is the very important definition. So we must know that Brownian motion is the random continuous motion of gas molecule. So Brownian motion connect with gas molecules motion. There are intermolecular space between gas molecule are more or less constant for different gas. But anyway, this distance is very big comparing with liquid or solid. Gas is compressible, but liquid is not. Gas is compressible due to the distance between molecules. When you push the particle together, they will go through the distance between them in the gas. But in liquid, the distance is very small. So this means the liquid is uncompressible. Now let's start to talk about gas laws, with which they are Boyle, Charles, and pressure, which has another name, Joly law. As you see from this part, the relation between Boyle, pressure, and Charles. Boyle is the relation between pressure and volume. Pressure is the relation. The pressure law is the relation between the pressure and temperature. Charles is the relation between volume and temperature. Boyle law, this is according to Boyle law, the pressure and volume of gas are inversely. Increasing pressure decrease volume and vice versa. From this, we conclude that BV equal constant, or B1 V1 equal B2 V2. Or another relation, we can say that B1 over B2 equal V2 over V1. This is due to the inverse relation. As you see from the graph here, it shows the inverse relation between volume and pressure. This is inverse relation. But 1 over V and pressure give you straight line come out from 0. Number 2, Charles law. Charles law, or Charles as scientists, study the relation between the volume and temperature when the pressure is constant. As you see, he said that according to Charles law, the volume of a gas proportional to the Kelvin temperature, and we will know that Kelvin temperature is the Celsius temperature plus 273 degrees when the pressure is constant. From here, V1 over T1 equal V2 over T2, or V1 over V2 equal T1 over T2. This means it's direct relation. As you see here, this is a graph for Charles law. From the graph, you see that all the law come as a straight line starting from this point called absolute zero. Absolute zero is not the 0 Celsius, it's negative 273 Celsius, which equals 0 Kelvin. And we will know a definition for this later. Number 3, the combining relation, combining the 3 laws together, Boyle, Charles, and Joly. Here again, a summarizing for this part. Boyle law, as a definition, the volume of a fixed mass of a gas is inversely proportional to the pressure. P1 over P2 equal V2 over V1. This is inverse. Here another an example or problem. I want you to try to solve it. The result will be 100 cubic centimeter. The volume of a gas 300 cubic centimeter under pressure 20 centimeter mercury. If the pressure of the gas increased to 60, find the volume at constant temperature. Number 2, Charles law, which is V1 over V2 equal T1 over T2, and this is direct relation, knowing that we use Kelvin temperature, which is Celsius plus 273. And another problem, and this is the final answer, try it by yourself. Joule law, which is relation between pressure and temperature when the volume is constant. The pressure and the temperature, there is a direct relation between them. So P1 over P2 equal T1 over T2. Also, we use temperature by Kelvin, which is Celsius plus 273. General law or combining law take the three together. P1 V1 over T2 equal, this is T1 equal P2 V2 over T2. Temperature is used by 273. This is at STP, standard temperature and pressure. The temperature standard is 273 Kelvin and the pressure standard is 76 centimeter mercury. This is the problem about the combining law or general law. Note that STP, this is a temperature standard and this is a pressure standard. Now we have very important things. It's called absolute zero, which we mentioned from a minute ago. What is absolute zero? Absolute zero could be defined by two definitions. Number one, both of them start with it is the temperature at which volume of ideal gas vanish. Volume vanish when the pressure constant. So it is temperature that volume vanish when the pressure is constant, or the temperature at which pressure vanish when the volume is constant. Both of them talk about absolute zero, which is 0 Kelvin and negative 273 Celsius. Thank you for your time, and I hope you get the information. If you have any question, I'm free anytime. Thank you very much. Bye.